Hi, my name is Christian Ramos, and this is my Physics 2 Lab 2. A little table of contents. So we're going to have the introduction, then we're going to show some models, go over the experiment again, see the new code, and then we're going to discuss it right at the very end. So what is the purpose of this lab? We're using charge tape to model two tapes as point charges. Then we're using GlowScript to split the tape into several point charges to better calculate the electric charge of the tape. So the difference between lab 1 and lab 2 is that lab 1 was one individual point charge, and now lab 2 is several point charges. So the 1 point charge for lab 1 was the electric force, or the electric charge, and then for lab 2, we're going to use superposition to calculate the total electric charge there. So we use Coulomb's law, which is 1 over 4 pi epsilon naught, Q1, Q2 over R squared, and Newton's second law, force equals mass times acceleration to find the charge on each piece of tape. And then we use the tape as point charges to model Coulomb's law, and then we're going to calculate the total electric charge using superposition. Models now, as you can see on the right side, we have the lab 1 model compared to the lab 2 model. So in lab 1, we modeled the tape as one individual point charge to the midpoint, and in lab 2, we're modeling the tape as multiple point charges and using superposition to find the total charge and force on the tape. So a couple of assumptions: we're going to ignore air resistance on the moving object. We're going to treat the long tape as if it was a point charge with all charge concentrated at the center of the long tape. That was some of the assumptions we had in lab 1. And then we're going to assume that each U-tape I made had about the same amount of charge evenly distributed along the length of tape, so it's just going to be an uniformly distributed charge throughout the entire tape. So this is the same experiment we did in lab 1, so we're going to take the exact same results, didn't do it again, we just take the same thing and we use it for lab 2. So the tape began to float at a separation distance of 0.03 meters. Each tape experiences a charge of 1.4 times 10 to the negative 8 coulombs. The calculations for the charge, so we had the gravitational force, which we just took the mass of the tape times the gravitational constant, 9.81 meters over second squared, and we found that force in newtons, and then we took that and set it equal to Coulomb's law, which is 1 over 4 pi epsilon naught q squared over r squared, with r being 0.03, and then eventually we found that the charge on each piece of tape is 1.4 times 10 to the negative 8 coulombs. So on the very far left, as you can see, we put in the mass of one tape in kilograms, the charge on each piece of tape, the length of one piece of tape in meters, as well as the distance between the tapes in meters when they start to float. Then we go and we make a function to calculate our electric field. So as you can see there, the final one is E equals K, which is the electric constant, 1 over 4 pi epsilon naught, times Q, which is the charge, over R mag squared, which is R mag squared, the square of the magnitude of R, which is the observation location minus the charged particle position, times R hat, so that's the very end there. And then as you see on the very right here, after we calculate our arrows and the sizes and all that, we have that the magnitude of the electric force is 4.85 times 10 to the negative 4, and the magnitude of the gravitational force is 1.96 times 10 to the negative 3. So now we can ask ourselves, why is the tape not falling to the ground even if the gravitational force is stronger than the electric force? This is due to the normal force exerted on the tape due to the surface of which it rests, because it's taped onto two surfaces. In our case, we use textbooks, so that's the reason why that's holding it up and using that force, that normal force there. Discussion: what if we had modeled each tape as a single point charge like the previous lab? We would result in a higher magnitude value of electric charge due to there only being one general point charge for the entire piece of tape, and that is why we'll get to why of this happens in the second part. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? So these differ because of the superposition used in lab 2 instead of the single point charge used in lab 1. I think lab 2 represents a more accurate model because the objects do not have to be objects in the real world are not just one point charge. There are a multitude of charges that lead to like a total electric charge. So having multiple electric charges, point charges modeled there at the tape is a more accurate model, because as like an actual piece of tape, it's not going to have just one point charge, but like lots and lots of point charges and lots of electric charges and electric fields coming out of that tape.